Hello, everyone, and welcome to today's briefing on the science and research cargo headed up to the International Space Station aboard Orbital's Cygnus cargo spacecraft. Orbital's Antares rocket is scheduled to lift off tomorrow at 6:45 p.m. Eastern Time from Launch Pad 0A at the Mid-Atlantic Regional Spaceport here at Wallops Flight Facility in Virginia. There are more than 1,600 pounds alone of science cargo headed up on board Cygnus, and to talk about some of those investigations and how they'll expand the research capabilities of the space station crew are Camille Aline, Assistant International Space Station Program Scientist, Brian Talbot, CASIS Director of Marketing and Communications, and Jeff Goldstein, Student Spaceflight Experiments Program Principal Investigator. For those of you watching on TV today, we'll take questions using the hashtag AskNASA. And with that, we'll go ahead and start. Go ahead, Camille.
Thank you, Rachel. Hello, good afternoon. Thank you so much for joining us today. It is our pleasure to share with you some of the science that will be launched on tomorrow's Orbital Cygnus spacecraft, which brings additional critical U.S. capability to ensure the successful research activities that are going on board the space station. The Cygnus spacecraft can accommodate a variety of scientific payloads within its pressurized cargo capsule. And this particular launch will carry a little over 680 kilograms of science payloads, which, as I understand it, is almost about a third of the total supplies that will be delivered tomorrow to the space station. Over the course of a year, we conduct hundreds of experiments on board the space station in a variety of disciplines, including biology and biotechnology, human research, physical science, Earth and space science. We do technology demonstration and development, and lastly, education. To date, we have conducted about 1,600 investigations on board the station that represent approximately 1,500 scientists from about 69 countries around the world. These results that are analyzed really help to advance our core knowledge of the natural world around us. It also enables us to further explore our solar system. And finally, it contributes to improving the quality of our lives here on Earth. This particular launch will send supplies necessary to support the ongoing investigations across the several disciplines, but it will also send up some new investigations that we'll share with you here today. The first investigation I'll talk about is called Meteor, and it will be the first space-based observation of the chemical compositions of meteors entering Earth's atmosphere. As you know, meteors are relatively rare, and they're really difficult to monitor from the ground because of the interference of the Earth's atmosphere. So it's really exciting to be able to study them from the vantage point of space. This investigation was developed by the Southwest Research Institute, and it uses high resolution video and image analysis to determine the physical and chemical composition of meteorite dust. This analysis will include characterizing the size, the density, and the chemical composition of the meteors. Investigating these compositions of the meteors adds to our understanding of how planets are developed. Continuous measurements of the meteor interaction with Earth's atmosphere also could spot previously unseen meteors. The second investigation I'll talk about is one of our human health experiments called Drain Brain, and this is sponsored by the Italian Space Agency. It will try to determine how blood flows from the brain to the heart in the absence of gravity. Understanding this blood flow makes it possible for researchers to develop countermeasures to treat headaches and other neurological symptoms that have been reported by crew members living on board the space station. There is a special neck collar that will be used to measure the blood flow from the brain, and it does not require special knowledge to operate. This could make this collar a useful tool for monitoring patients on Earth who have heart and brain disorders. Drained brain also could have implications for development of screening mechanisms for cognitive diseases like Alzheimer's disease. The final investigation I will talk about today happens upon re-entry of a spacecraft. On board the Cygnus is the re-entry breakup recorder we call REBA, and this one is equipped with wireless sensors. This device will be placed on the ATV-5, and it records data during the re-entry and breakup of the vehicle from wireless sensors placed throughout the host vehicle. The data returned is analyzed and used to design future spacecraft that minimize hazards to both people and property on the ground. So again, these investigations are just a sample of the science that is enabled by tomorrow's orbital launch that contributes to the advancement of human exploration and as well as our daily lives here on Earth.
Great. Thank you, Camille. It's really exciting to be here today to talk about the week's launch, as well as what's been a month of exciting developments for the ISS National Laboratory. As the managers of the National Laboratory, CASIS was tasked with 3 key areas of focus for the organization. 1, to create innovation cycles where first-class science is driving new technologies, intellectual property, as well as commercial and product opportunities. 2, to utilize the ISS to develop new capabilities. And 3, education and outreach, to use the ISS as a premier platform for inspiring learning and discovery. The developments in October all represent major strides forward as well as small steps forward in each of these areas. So in regards to innovation cycles, CASIS's strategic objective number 1, CASIS just announced a series of life sciences investigations from Baylor College of Medicine, Houston Methodist, as well as UCLA. These will look in areas including osteoporosis, personalized medicine, as well as genomics and an omics platform. We also just released a new request for information that's going to enable disease model research to accelerate space research and understanding human disease, identifying drug targets, as well as evaluating new therapeutics. Also this month, we introduced a request for proposals that was announced that will explore Earth observation in order to benefit energy technologies. And finally, we're very excited about science experiments that returned yesterday on the SpaceX capsule on our first protein crystal growth experiments. So those looked at cystic fibrosis, Huntington's disease, as well as Parkinson's disease. So we're very excited to find out the results from that. In regards to new capability, CASIS's second strategic objective, last week we introduced a suite of 6 funding awards as part of our Enabling Technologies Request for Proposals that was put out earlier this year. We received a great response to this RFP, and technologies came from a diverse mix of companies. In the essence of time, I just want to highlight 2 of those products, which I think are pretty exciting. The first comes from Dr. Doswell of Juxtopia. So they're going to be developing an innovative augmented reality goggle system. So the comparison technology would be a Google Glass, but it's built for the ISS. Those augmented reality goggles are going to provide virtual assistance that seeks to improve the speed and accuracy with which astronauts can perform ISS National Lab experiments. Moreover, there are already Earth-based markets for these technologies when you think of hostile environments for emergency responders as well as austere or extreme environments. The second technology that's pretty exciting coming out of that request for proposals was the intuitive machines that was actually featured in Popular Science earlier this week. So they're going to be testing a terrestrial return vehicle that addresses the need for small priority payload return from the ISS. So you'll be able to deliver up to 30 liters of ISS payloads much faster and easier. So we're very excited about those as we think they're going to help drive further utilization of the ISS. In regards to education and outreach, which is the third CASIS strategic objective, this flight represents a great opportunity there. So the mission is going to be launching 16 CASIS-sponsored research experiments, the ISS. These were developed through 2 national STEM programs, both fostering a love for learning among elementary and high school students. 10 of those experiments Jeff is going to be talking about in a little while, which is a part of his portfolio from the Student Spaceflight Experiments Program. This is their 6th mission, and CASE is a very proud sponsor of that program. The other 6 investigations are coming through the CASE's National Design Challenge, and those are coming from the Houston community. So within Houston, we've selected that region to introduce space-based research to that community. All 6 of those are coming from that area, and we're excited to represent Cristo Rey Jesuit, Audi International School, as well as Duchesne Academy, which I'll be sending experiments up. And we're also very excited that the Cristo Rey Jesuit community will be here tomorrow to watch that launch. So in summary, this is a very exciting time for the ISS community, from new users in government, commercial, and academic, to really life-changing opportunities for student communities. There's a lot of great progress and opportunity.
Well, Rachel, thanks for having me. It's wonderful working on this program with NASA. And I'm here to talk about the Student Spaceflight Experiments Program. I'm the Center Director for the National Center for Earth and Space Science Education. We're a nonprofit, and the center, in partnership with the Arthur C. Clarke Institute for Space Education, oversees the Student Spaceflight Experiments Program, or SSEP. The reason we're here today is because we have the Yankee Clipper SSEP Mission 6 to ISS payload going up on Orb 3. There are 18 experiments. We just had 15 come down on SpaceX for Mission 5, which was launched in July on Orb 2. It's really exciting for us to have been on all 4 Orbital Sciences launches to the International Space Station. And it's kind of amazing to think that just in 4.5 years since program inception, this is now our 8th payload going into orbit, the first 2 on the final space shuttle flights and 6 to ISS. I'd like to just acknowledge a number of partners here. We do this in concert with our strategic partner NanoRacks, which flies commercial payloads through a Space Act agreement with NASA. And we are also very proud to be in national partnership with the Center for the Advancement of Science and Space, or CASIS, as well as Subaru of America. And each of the flight opportunities for SSS works with a network of communities, which at the local level represents a network of local partners. So for Mission 6, we have over 100 partner school districts, companies, foundations, universities, and other research institutions that make this possible. The 18 Mission 6 experiments represent over 6,500 students in grades 5 through 15, so that includes 4-year colleges and universities, working on microgravity experiment design, and over 1,400 proposals that were submitted by student teams for flight experiments. So let me first give you a sense of how SSEP works. It's essentially a call for proposals, and the idea is to absolutely mirror how professional researchers do their thing. If there's a limited professional research asset that NASA has available, not enough to go around to the research community that wants to use it, NASA will issue a call for proposals, and researchers all over the country will design a research program that makes use of that asset and propose to make a case, justify why they ought to get the asset as opposed to some other group. And there is a review and selection process to essentially identify who gets the asset. Well, SSEP works the same way. Every one of the participating communities gets a limited research asset, which is a microgravity research mini laboratory, a fluid mixing enclosure, and I'm showing this right now. Very easy to use, very straightforward, very powerful, the community gets guaranteed launch services to get that mini lab to ISS and return it safely to Earth for harvesting and analysis. And so the mini lab can only contain a single student team designed experiment. So each community, through a team of educators, will engage typically 300 plus students in real microgravity design and experiment design and proposal writing. Those students will break into teams of typically 3 to 5, and each team is designing their own microgravity experiment, and each team is, there's fly isn't here. Each team is writing their own proposal, and typically 60 to 120 proposals are seen across a community. And all of those proposals go through a two-step review process, and the National Review Board that meets at the Smithsonian's National Air and Space Museum will select the flight experiment for each community. So that's how it works. What we're doing is we are immersing thousands of students in every facet of real microgravity experiment design and proposal writing so that we can inspire and engage the next generation of America's scientists and engineers, and Canada's, by the way, because we have a community, our second community from Canada, on the Mission 6 payload. So let me just say that with regard to this mini lab, very powerful. It's simply a tube that can be sectioned into up to 3 volumes. And one can imagine, for instance, a biological in a freeze-dried format placed in one volume, a growth medium, say, in the second volume, like luria broth. And in the third volume, you might have a fixative like glutaraldehyde, which will kill and preserve the biology before deorbit and reintroduction into a 1G environment. So the students have to design against submission of the payload a few weeks before launch, so the experiments have to be put in stasis. They have to take into account the thermal controls along the different transport legs. They have to take into account the specific crew interaction days that NASA makes available and the crew interactions. They are constrained by this real operation of this mini laboratory and real spaceflight operations to and from low Earth orbit. So with regard to the experiments that are flying, there's a very large range of science disciplines flying on Yankee Clipper. We've got crystal growth, efficacy of composting in microgravity, a number of bacterial studies, including growth of coliform bacteria, efficacy of biocides on bacteria, E. coli attachment to lettuce, growth and development of mosquitoes and houseflies, seed germination and geotropism studies, hydroponic studies, microaquatic life in the form of development of fairy shrimp, and rate of food spoilage. So it really is a very diverse array of experiments. In the press package is a table that lists all of the 18 communities, their experiments, their teams, their grade levels, and 8 of those teams will be at launch. We've got 150 delegates at the launch, and there'll be NASA has invited us to do a media briefing tomorrow where all of the teams will be presenting on their experiments. So let me just say in closing, this is Koichi Wakata activating one of the mini labs on orbit. This was a Mission 4 mini lab that went up on Orb 2, and this is happening in January. The next slide is a picture of our team from Ocean City, New Jersey, which is looking at E. coli attachment to lettuce. And this third image is a DC team, which is looking at chrysanthemum seedling development. And let me just say that the DC team is our first 4-year college and university community, led by American University and a consortium of 7 metro area universities. And these students participating are future science teachers. So the idea was to immerse future science teachers in research so that they could see how it works. And let me also say one last thing about another team from North Charleston, South Carolina, who are here, and I see them in the audience, somewhere in the audience. What's interesting about this team is they're looking at whisker growth in microgravity. These are whisker-like metallic crystals that form on printed circuit boards, a real problem in microgravity. And the reason I mention them is that this team submitted a proposal last cycle, and got as far as the finalist stage. And they did not get selected, but based on the strength and weaknesses comments of the review panel, they resubmitted, and now they're the flight experiment. And that's exactly how professional research happens. So I wanted to point that out because we thought that was a wonderful example of how this program is supposed to work.
Okay, we'll take some questions from here in the room. And as a reminder, if you have any social media questions, you can send those to us using the hashtag AskNASA. Go ahead, Ken.
Hi, Ken Kramer, Universe Today and America Space. I have a question for Camille and for Jeff. From Camille, can you talk about this meteor experiment a little bit? What does it involve? How are the astronauts involved? It's very interesting. And for Jeff, I'd like to talk to you about Senator Coburn. He criticized your program. I find this extremely disheartening as a scientist that he would criticize student scientists. So I would like you to respond to his criticism. Thank you.
So to your first question, the meteor investigation includes hardware that is both video and imaging capability, and it will be set to take those images of the meteor as it's flying through the atmosphere. So developed by Southwest Research Institute.
Is it passive or active?
It is active. The camera equipment is installed in the wharf, which is a window observation facility on board the ISS.
Ken, I knew this question was going to come up, and I just wanted to read the quote from Roll Call. What Senator Coburn said was, while encouraging young people to take an interest in science is an important goal, the billions of dollars being borrowed to support space station science fair experiments could make a bigger impact in the lives of these and other children in many other more cost-efficient ways. We were very disheartened by that statement. The first thing is he's putting this in a very derogatory sense. I mean, as I said before, these are thousands of students being immersed in real research to see it for themselves. And these students are the next generation of scientists and engineers. These students are in the pipeline to ensure that America's space program can continue for decades to come. This is really important stuff. And to diminish what these student researchers is doing is not right. The other issue is he's way off the mark with regard to funding. He's saying that there's billions of dollars being spent in support of these programs. Let's set the record straight right now. Whenever a community comes aboard, and let's take Mission 6, the cost to our nonprofit, full cost recovery, is $21,500 to support one community. And we've taken the precedent-setting step to work with those communities to find a consortium of underwriting partners in the private sector to build that funding, and we've been very successful. So for Mission 5, which is what he was talking about, the total program cost was $622,000 when you roll in the fully burdened labor hours of the teachers involved. And we raised $572,000 in the private sector. And the reason that the $50,000 was allocated from space station federal dollars for operation. And where did that $50,000 come from? It came from our wonderful national partner, CASIS, because in many of these communities, we work really hard to get to that 21.5, and there might be this little delta left over, a couple of $1,000, and if we can't fill that budget shortfall, they can't participate. And CASIS gives us $50,000 a year per mission just to fill those gaps to get those communities aboard. So we're talking about 8% in federal dollars on this mission. The next mission flying, it's just 4% on federal dollars. And CASIS, by the way, and you can speak to this, one of its strategic mandates is to leverage STEM education on the International Space Station. So you can see this is a hot button for me.
Okay, other questions? Moving on social media? Let's go here in the front.
All right, this first question comes from Twitter user Launch Complex, who asks, are any of the experiments designed specifically to fly with Cygnus, or could they fly aboard any vehicle?
I'll say they can fly aboard any vehicle, but it must be a pressurized vehicle. So Cygnus provides that capability of launching pressurized cargo.
All right. Twitter user Kieran asks, how much space does the payload from the SS EP6 experiments prepared, how much does that take up on the rocket?
I believe it's either 10 or 12 tubes in a payload box, which is a 2U box about this big. And so if we have 18, that's two 2U boxes, so 20 centimeters by 10 centimeters by 10 centimeters.
All right then. Kryptonite here asks, what is the goal overall? Why are we doing science with this? Why are we launching all this?
Well, our goal for doing research on the space station is threefold. One is to really advance our knowledge of understanding our environment, our natural environment. I think that is what science is. It's the understanding of the natural environment around us. Secondly, is to enable us to further explore space. And thirdly, to contribute to the benefit of humanity's life here on Earth.
And let me add to that. I think that any parent recognizes in their children when they're very young that we are born curious. We are born to explore. It's wired in us. That's what it means to be human. And we as a species are curious about our place in a greater space. We are wired, we are born to go forth. And the International Space Station is part of that mandate. We are born to go forth, and we do these things because we are meant to do these things.
Let me just add briefly, too, there's just certain characteristics of doing microgravity research that is the only place in the world and in the universe where you can turn the gravity vector off. And so there's unique things that you can do from a life sciences perspective, from a materials development perspective, from an Earth observation perspective that you just can't do anywhere else. So that's why ISS experiments are so important to improving life on Earth.
Okay, other questions here in the room? Let's go here near the front.
Hi, my name's Mandy. I'm with NASA Social. I'm actually an occupational therapist, so I work with a lot of Alzheimer's patients and dementia patients. So I was curious about when would the device that you were mentioning that scans for Alzheimer's, is that something that we could possibly see in the near future? And I mean, if so, how exactly would it go about scanning for Alzheimer's? I mean, I don't know if you know the details, but at least is it something that we could see in the near future?
So this is the first time that this investigation is being conducted on the space station. So tomorrow's launch enables this equipment to go up to the space station and for researchers to really study this phenomenon of how the blood flows from the brain to the heart in the absence of gravity, because gravity is an important vector in how our human body functions. And so not having that gravitational element in the equation really changes the dynamics of how the human body adapts. And so this investigation looks at that for the first time and allows researchers to really try and develop countermeasures to treat the types of symptoms that astronauts are experiencing in this space adaptation environment. So I think that it probably will be a while before this equipment comes back and is really spun off into something that can be used for Alzheimer's patients, but that's definitely a potential benefit of this investigation.
Okay, other questions?
Chase Turner, NASA Social. My question is, well, I have two. One is, with the telemetry for the rebar program, is that something that amateur radio operators around the world will be able to listen into? And my second is, what sorts of CubeSats are being launched? Is it from around the world or just American universities this go around? I'm sorry, I don't know who to ask.
You can.
Thank
Jeff,
you.
You want to take the second
No,
one?
I don't think, I'm not the right person to ask about the CubeSats.
We can find out and get back to you.
I don't know about the CubeSats.
I know that NanoRacks is launching quite a few CubeSats. So you might want to go to the NanoRacks website. I mean, they're one of a number of organizations, but you might want to go to the NanoRacks website and see what they're doing with CubeSats.
And in terms of the first question about amateur radio enthusiasts being able to probably pipe into the telemetry data, it depends. It probably depends on the frequency by which the data is being collected. So that will be the dependent factor.
Okay, other questions? Sure. Wait for the mic, though.
Okay, cool. Oh, no, I hear it now. So is the, I have a lot of questions about the meteor thing, because planetary formation is like my jam. So, so you just basically take pictures of it, and you're going to analyze just that image data, or are you going to be able to, like, grab onto any of them and stick them into, like, a chromatograph or anything like that? What's the deal?
So I'm not the principal investigator of that investigation, right? But the idea is that you take the images and the video from the vantage point of space without the interference of the Earth's atmosphere. And that's probably going to give the researchers and scientists a clear understanding of the composition of meteors, which they did not have before.
Okay, other questions? All right. Well, I guess that'll do it for us. You can find out more about all of the space station science happening on board our orbital laboratory, as well as the cargo headed up on Cygnus tomorrow at www.nasa.gov/orbital.